Can you give us kind of, from your perspective, what does it mean for us now as a species, as a biosphere, that we know that exoplanets exist? And what is your side of the research in looking into exoplanets?
When I started research, there were no known exoplanets. Most of us in those days started out as stellar astrophysicists. We were studying the stars. That was helpful because the way that we were discovering planets was to observe something about the star that inferred the existence of the planet. So that was my pathway to exoplanets. I was actually at the conference in Florence, Italy, where Michel Mayor announced the first exoplanet. And so I feel like I've had a front row seat to this new field being born, and then also becoming part of it, and not just observing from the sidelines, but being enmeshed in it and understanding that feeling of discovering a new world and what that means, starting out as an abstraction. But as you learn more, it becomes less of an abstraction and more of an actual physical place that you can imagine. You can use your empathy to actually place yourself there and imagine what it might be like. So, as that unfolds and as humans learn more, the knowledge seeds itself into our public consciousness, our collective consciousness. And it slowly transforms how we see ourselves in the universe, as part of the universe, as part of a living world, not separate from that planet, but part of it. And I have certainly observed that happening with me, and I've seen it happen with the people I talk to as well. One of the most marked moments was after Kepler launched, and we had already discovered hundreds of planets, and we were using that information to deduce how many planets are therefore in the galaxy as a whole. And one of the early results that I kept seeing over and over, and probably didn't even appreciate it at the time, was that the average number of planets per star is greater than one. And so as I look at the sky now, I see the sky differently with that knowledge. Now I know that these stars are not just stars, but planetary systems. And so it's a subtle thing. You don't realize how much it impacts us as a species. But now the narrative has changed so much. Now that Kepler has finished, it catalyzed the search for life. You can't help but knowing that the nearest potentially habitable planet is likely to be within 10 light years, that there are literally billions of potentially habitable worlds in our galaxy alone. You can't help but wonder how many living worlds are out there. So now we are just hyper-focused and driven by this singular question, and everything we're doing is just a waypoint towards that broader goal.
Yeah, I love that vision too. Like looking at the nighttime sky when I was a kid, I saw these dots of light, and now we can envision them as, systems and stars with planets and maybe asteroids and comets of their own, and maybe even biospheres in some of those worlds. That's rather remarkable. Some years ago, I was taking a graduate course at CU Boulder, and Nick Schneider was one of the professors. And I remember Nick said this really funny thing that like everything we thought we knew about planets changed once we started finding exoplanets, and that keeps changing. I wonder, is there anything that you think is changing right now in our understanding of worlds around stars because of all these detections of exoplanets?
Absolutely. I mean, you go back to the very first planet discovery. That hot Jupiter 51 Peg B was already a huge surprise, and we are still reeling from it. We think we have a decent explanation, but we don't have concrete proof that our explanation is correct. That will in part be tested by Webb in the future, how a giant planet can form 10 times closer to its star than Mercury is to our sun, for example. So the entire field has been filled with surprises. The most common type of planet that we know of so far in the galaxy is a kind of planet that we don't have in our own solar system, where you have the small terrestrials orbiting close to the star and the large gas giants orbiting far away with nothing really in between in terms of size, tiny versus large. And yet in the galaxy, again, the most common type of planet orbiting within one astronomical unit is this mysterious in-between planet. Are they scaled up Earths? Does that represent more real estate for life? Or are they the stripped cores of Neptunes, former Neptunes? And if so, what are the implications for the evolution of life on such a world? So many questions have been opened up, and again, we hope to answer some of these with Webb. But we've also learned from Kepler that the diversity of planets in the galaxy is staggering. That's just one example of a kind of planet we don't have in our own solar system, but there are many others. There are lava worlds with oceans the size of the Pacific of molten rock. There are planets orbiting not one star, but two. There are planets the age of the galaxy itself, which we didn't think was possible because we didn't think the raw materials would exist that early on. So, I mean, the list is endless. So there are endless horizons to explore, which is very exciting.